Hi everyone, welcome to Cloud on Air. My name is Jay Jenkins. I'm a customer engineer based in Singapore. Already this morning, we talked about Google Cloud Platform and how we can help you with G Suite, compute, analytics, and machine learning, and now we'd like to focus a little bit more on compute. Now remember, at any time, you can ask a question below, and we have technical experts ready to answer. Ashish Apilli has over 10 years of experience in IT, doing end-to-end deployments. And he's going to talk you through about how you decide where to run your code, whether that's on compute or containers or on platform as a service. So with that, I'll transfer you now live to Ashish in India.
Thank you, Jade. Thank you very much for the introduction. So, good afternoon, good evening, and a very good morning to everyone who is joining the show today. So, we're going to look at some of the services that are offered as part of GCP, and then we're going to go through each one of these things, and then we're going to discuss about the strengths that they have, what are the best fits for that, and then we also look at some of the constraints that you would face of these things. So, who is here today? So, I had a quick look at the list of registrations. So I had a lot of people are fairly new to GCP, and there are a lot of developers out there, and there are a lot of people from the IT ops organization as well. And this is perfect for that. So here are a bunch of logos, and so if you're already aware of these logos, chances are that you would probably know a lot about these products already. And I would request you to stay with us, and then you would probably pick up some nuggets as we go along. So these are the four primary places where you could run your software or your code. We're going to talk about these four services throughout this talk. So the compute engine, which is at the bottom, so comprises of the VMs, is basically the virtual machines, and the network that goes along with it. So the rest of the stack, rest of the services actually run on top of compute engine, and that's why I've actually put them one above the other in a logical way. Container engine is hosted Kubernetes. This is a system for running a lot of containers on top of the VMs. And the app engine is the original Google Cloud in a way, released back in 2008. So the idea is that you push the code and we will run it for you. And then cloud functions, this is just one function. There's an input, you do a little bit of modification, and then there's an output at the end, as simple as that. Now, to simplify, so cloud functions is event driven, and the app engine is mostly for the web facing applications, and container engine for the containerized applications, and then compute engine is for the existing systems. This is really great for the lift and shift systems that you're currently running probably. Now, so where should I run my code? Now, like all good things in your life, it actually depends, and it really depends. So let's look at these four services. So we're going to look at each one of the services as part of the agenda, and then we're going to give you a brief idea as to where you could probably fit your code or where you can run your software, and then we'll also guide you through some next steps where you can get started, and then try some hands-on on each one of these services. So making the right decision. So at the end of this session, if you're unable to make a decision as to where you would probably want to run your code, not to worry at all. It's a very low risk decision. So we'd also give you some guidance around where you could start, and then how it's easy for you to move up or below the stack. So without further ado, let's start with compute engine. So compute engine is basically the VMs, the virtual machines, and the networking that goes around with this. And if you talk purely about numbers, you could go as high as 64 CPUs, or you could get 416 GB of RAM, or you could allocate 64 terabytes of disk, or you could also use GPUs if you're training your machine learning models. All of these components are individually configurable. There's a slight ratio between the RAMs and the CPUs that you use, but more or less you could play around with that. They're extremely fast. The average time a VM takes to boot is about 30 seconds, and within 30 seconds, it actually provisions a VM. And then if you have a startup script included in that, it'll run that, and on top of that, it'll run the operating system, and then it'll run your code that's on top of the machine. So it's pretty quick. So we have a bunch of preloaded operating systems that are available as part of when you configure, and or else you can bring your own operating system and then we'll run that for you as well. Disks. So disks are amazing. So we love network-based disks. So we would say, you could go as high as 64 terabytes, and if your application actually needs a SSD drive, so you could attach that. We would work with that as well. But the idea is that the larger number of disks, the higher throughputs. It's kind of correlated. And if you really need a local SSD attached to the hardware where you're running your applications, we're happy to do that as well. Cool. So it's not just the VMs. So I would like to think of it as a certain set of an extension to the basic compute that you're doing on-prem. So let's say if you want to run a single Docker on a single machine, it works. It absolutely works fine. You could do that. And there's a concept called managed instance groups, using which you can create your own templatized images. You can host them, and you can set them on an auto scaling mode where you scale up or scale down based on the traffic that you would probably get through to your application. You can also span them across multiple regions so that you get the reliability that you need for your applications. And when you have the managed instance groups, it's really easy to roll out updates onto your application. And the load balancer that you get as part of this is also a global load balancer. So you can scale from 0 to 1 million requests per second without any pre-warming, or you don't even have to talk to us. It just scales up. As simple as that. As a software developer or an IT ops guy, when I look at this, it's like a virtual infrastructure where I can run my software or bring my operating system that is required, configure and customize the disks images that I need, get the CPUs or RAMs or disks. You can customize each one of these, and you can also build your networking around this. You can build your firewalls, you can build a load balancer around this, and you can also build your virtual private networks around this. So you could do pretty much everything and almost everything that you could do in an on-prem world. So constraints. So as I've said earlier, so each VM takes an average of 30 seconds to boot up. So if you have an application which needs to scale up at really fast, then you need to rethink which architecture that you would probably use. And then when you have a lot of VMs working together and you have to roll updates across different VMs, this could be slightly difficult in terms of managing that. However, but it's a fantastic fit for lift and shift. Anything that you have, you could just lift from your on-prem or other clouds, and then you can bring over here. So if you want to do a one-to-one mapping of a container, you want to run one container or VM, that's good too. If you have a specific OS or kernel need, or if you have licensing requirements, or if you have to run a GPUs, or if you have to run your databases, that works too. Anything, so the network, so it works from layer 3 and above, so you could use anything beyond HTTPS with compute engine as such. So let's do a quick demo and see. I'll probably quickly walk you through the demo. I've set up a project for this. So I will. So these three buttons, these three lines at the left top corner on the console is the most important thing on the console for you. So this gives you access to a number of services that we host on Google Compute Engine. So let's go to Compute Engine, and you could see a bunch of VMs running here. So let's create a new one for the demo. And I would probably name it as Cloud on Air. So once I do that, so you could see, you could select the zone where you would like the VM to run from. So there are a bunch of zones in Asia as well, and we are going to add more over the course of this year. So for the sake of this demo, let's run from US Central A. And there are predefined ratios where you could select in terms of the CPUs and the memory. So you could have a 2 CPU and an 8 GB memory, 4 CPU and a 16 GB memory. But you could also customize. So this is where you could customize. So you could drag and drop and then create some weird kind of cores to machine ratio. But it's up to you. So it's completely up to you. How do you customize? So it basically depends on the application that you're running. So let's just pick a 1 CPU or a micro CPU to run with. And then you can also pick your operating system. As I've said, you have a bunch of operating systems that are pre-built and preloaded. So you could select any one of these, so ranging from Debian, CentOS. You would also have Windows servers as well on top of this. You could also bring your own custom images or snapshots from someplace else. You can also have application images readily that you can select and build. You could go to the so I would probably select a size 10 GB of the disk, and this is where you could define the access for the APIs, and then you can play around with your firewall rules over here. So let's just create one quickly, and there it is. So while it's firing up, it won't take more time. It takes an average of 30 seconds, I've said earlier. So we'll just wait for it to fire up, and then you can see I'm going to SSH into this machine because I'm already logged in using the OAuth credentials. So once I click on, so there's a small button which is going to come up here. So there it is, the SSH. So once I click on this, based on the OAuth authentication that I've already had with the browser, you could log into the machine directly using exchanging the SSH keys, and you can SSH into it. And then once you're logged into it, you are ready to go and run whatever you want to run. You can install software. You can, you're all set, to be honest. So we'll just wait for a second for it to boot up. So while we are doing that, so we could talk about the billing. So, oh, there it is. Sorry. So let me just run a quick command. And you can see a bunch of software is being installed on this pretty quickly. Yeah, so that's done, and then I'm all good to go with this. So let's exit the demo, and then we'll go back to the slides to talk a little bit more about these things. All right. So why Compute Engine? So from a Compute Engine perspective, we would like to bring you a lot of consistency into the VMs that you're selecting. So let's say you select 10 VMs today, or you ask 10 VMs, you get 10 VMs. You test your performance based on today with the 10 VMs, and then you do a test 10 days down the line. So you would get the same kind of consistency whenever you do that. So you could customize your VMs. You can choose the RAMs you want. You can choose the CPUs that you want, or GPUs, to be honest. I mean, it's pretty much customizable around the space. And you can also do a live disk resize, and there have been a number of instances where you could see that you run out of the applications, and then you hit an outage. So you could increase the size of the disk and then mount them while the applications is running, so which is pretty cool. From a billing point of view, you get, so a bunch of things I can talk about, but essentially the idea is that the more you use, the more discount you get, as simple as that. For let's say for batch jobs which are slightly fault tolerant, you could also run preemptible VMs which are very, very cheap. And you could do live migrations, and then it's a good fit for a lot of architectures out there for the existing system. So essentially for the lift and shift from your current on-prem data center. All right, so now we move on to Container Engine. So Container Engine, so as part of my job, I interact with a lot of customers and a lot of developers. And then when I talk to them, a lot of them are actually interested in containers. Either they are planning to deploy their applications in containers if they're not already doing it, because it's exciting. And then why am I excited? Because for containers, you get a very, very good performance, repeatability. You could repeat that. You could run in a container, and you can run the application any place else. You get isolation from other processes that are running on the servers, and then really portable. You can move from your on-prem to other cloud vendors and also to Google Cloud as well. So fundamentally, it's a different way of managing your applications. Kubernetes. So Kubernetes is a system, is an orchestration system that's been inspired from Google's internal systems. We have applications with more than 5,000 plus nodes, which are running on this Kubernetes. It's 100% open source. There are a lot of communities which are actually contributing to Kubernetes as of today. And the idea is that you manage applications and not VMs. Right. So when you think of Kubernetes, it's a logical architecture. So you think of application alone and not the VMs or containers as such. So it's kind of a whiteboarding. So let's say you want to pull up an application with let's say 5 front-end processes. Let's call them X, and then you want them to interact with four backend processes, let's call them Y, and then these have to interact with your database, which let's call them Z. So when you draw the picture and then when you draw the lines which actually represent the data transmission, that's pretty much what happens in Kubernetes. And that's how you should think about your Kubernetes. And why container engine? So container engine is actually hosted and managed Kubernetes for you. So it's going to manage the computer nodes for you. It's going to manage the software updates on this, and it's going to manage the cluster auto scaling, and it's going to monitor the health of the pods that are there. Okay. So why is it? Some of the constraints that you need to think of is you must use containers because it's container engine, and then so it has inherent challenges that a container would bring you to the table. And there are some architectural constraints such as the use of certain types of APIs. But besides that, it's pretty good to run any kind of any kind of applications in multiple environment clouds. So you want to host something, you want to host a hybrid environment out there. So Kubernetes is a good go for that, or for you to host a dev, test, and prod environments and move across your application code across all three environments. This is very good, and it can take a full advantage of the containers, so you get the best out of the money that you have invested into your resources. So I also like to think that it actually improves the communication between your dev, ops, and security. So you always have this problem of it's running on my machine, it's not running here. So you kind of solve that problem, and it's very easy to communicate when you're doing continuous integration and continuous deployment, and it works on all network protocols beyond HTTPS. So there you go. Let's do a quick demo on container engine. So like in cooking shows, I've already created a container. So I'll just connect the VM here, but I'll come here, and if you go to container engine, you could see I've created a cluster for you already, and it's running up there. When I click this, it shows a lot of configurations around there, and it shows an instance group that is supporting the cluster as such. And if I go here, this is the Kubernetes open source dashboard using which you can monitor your clusters. So if you look at this, let's have a quick look at this. So it says there are 4 nodes, so basically 4 VMs that are operating and supporting this. And if I go to services, I've created a service here called Nginx, which is basically a load balancer. So as part of the demo, we're going to do a quick demo of installing Nginx and running an Nginx server. So Nginx is a popular web server if you're not already aware of it. And let me open this. I'll just copy this and open it in the incognito window, so it doesn't pick up from this. So if you go here and then see, there are no deployments done here, so there are no pods running currently over here. So let me go here, and then you could see this nice little screen here where I could run the commands directly into the cluster. So let me just quickly run this command. So kubectl is a command that I can run within the Kubernetes cluster, and what I'm trying to do is I'm deploying a Nginx web server, and I'm pulling the image from Docker registry. The image is curated by the Nginx folks. So let me do that, and it won't take long. So oh, there it is. So the deployment is done. So get back to the dashboard here, and if I look at this and maybe go to deployments, and I can see an Nginx server here. Let me go here, and if you go to the service and open this, there you go, and there's your Nginx server running of Kubernetes. So when you come back here, you could see the deployments, or you could see the workloads over here, and you can see there's 1 pod which is running here. Let's just try and scale this up a little bit, so and see how quick it is actually to scale a Docker container on Kubernetes. Deployment Nginx, and let me create 10 replicas. Let's say 10, and I will do that, and that's done. So if I come back here and maybe refresh, There it is. So you can see how quick they are. So all 10 VMs are now up and running. It took literally few seconds for them to fire up and start serving the traffic. Cool. So let's get back to the presentation. So let's see why. Let's see why Kubernetes or container engine for your application. So because it's managed cluster, you just focus on application. You don't have to worry about anything else. It's very quick. You could start very quickly, and then when you're doing updates, it's really easy. Everything is automatic, so you could roll the updates pretty easily. And when you're running Kubernetes, you insulate the infrastructure from rest of the insulate from the infrastructure. So you're utilizing the maximum, and you save a lot of money around that, and the abstraction level at which it operates is really sweet, so you don't have to worry about anything around that. And you can also choose logging and monitoring for your applications, so that you know what's going wrong if there is anything. So next, App Engine. So App Engine, the goal is that it's a developer for the developers to actually focus on code while we handle the rest. So I could probably call it a serverless, but before it was cool. We started it in 2008 though. But the trade-off is that we say you write it in this way, and then we scale it for you. So we have also introduced fairly recently a new App Engine Flex environment where you could run a bunch of other runtimes like in Node.js, Ruby, Java, Python, Go, PHP, and .NET. And if that's not for you, then if it's an application that runs in a container, please bring the container and we'll run it for you as well. So when you think about the App Engine, you think about the code. So as a developer, you only need to think about code, and it's basically addressed for the HTTP request based applications. And versioning is really simple with App Engine, and we'll see that in a minute in the demo. And then from a constraints point of view, if you're using App Engine standards, so you're limited to use Python, Java, PHP, and Go. You can't use any other binary extensions. But if you're using App Engine Flex, which is flexible runtimes, it has the constraints of a Docker because the underlying technology is Docker, and it's not probably the best for a very low serving traffic. So for it to run, we have at least 2 VMs serving the traffic. So if you really have very low traffic and 2 servers or 2 VMs supporting it, you're paying for both, although you're not using for that. But if you're having an application which has a good amount of traffic, it's a good fit. So the idea is that anything for a HTTPS request response, so it's a perfect fit for that, and for this stateless applications as well. Snapchat is an example which is running on App Engine, and then you can see how they can scale for really high traffic when it's needed. Demo time. So let's go back to the demo. So I've created an App Engine service for you, so you could see on the screen. So there's a default service already available here. Let me just quickly click on it, and it could take you to a link, and it's saying it's a web server basically, and it's saying hello, this is version 1. So let me open that in a incognito window. So it's publicly served, so you can see it's available there. So no matter how many times I refresh this, I get the same version being served to me. So let's get back to the App Engine. So when you dig a little deeper into this, there are 3 different versions here that I've created already for you, and you can see that 100% traffic is being served from this version, which is version 1, and there's version 2 and 3 as well. So let's just say you want to split your traffic between version 1 and version 2. All you have to do is select the other one and split your traffic from here, and then let's say you want 100 on this, probably 50-50. So and then send half of your traffic to one version and half of your traffic to the other version. So let's say cookie based, and then you can split the traffic based on the IP address the traffic is coming from, or if you could place a cookie and read that as well. So let me see, and while I do that, it's updating the traffic split settings, and we'll go back to the application and try and refresh a couple of times and see where the application is being served. Let's go back here, and then there it is. So I've just refreshed it, and it says this is version 2. I'll do it again. This is 1, and this is 1. So it's pretty much 50-50. You could get either 1 or 2. It's a really good way to test your application and see how the users react to a particular version of your application. So you could do that. That's fantastic. You could also go back to the dashboard. So this is a demo icon, and a demo project. So there's not much to read from here, but for a production application, there's plenty of details that you could read from here. Or you could look at the latency and the traffic and the utilization of the instances, and then you can take some meaningful decisions on the application that you're running. So that's it. So let's go back to the slides and then move to the next topic. So okay, before we go there, so why App Engine? App Engine, it's basically for you to focus on the code, and so that we handle the rest. And it's really optimized for the web serving workloads. You have flexible runtimes which are possible. So if something is running on App Engine, you can create a Docker out of it, and then you can move and you can take the Docker to your on-prem or your own machine or to any other cloud provider. So you have the portability there, and you could also SSH into the instances that are supported in cluster, and then see if there's something wrong in it, and debug and see if there's something wrong. So you can kill the instance, and the managed instance group would fire up a new one for you should you need. So not many people know that App Engine is very, very popular. As of today, we have over 100 billion requests per day. So obviously there are a lot of applications that are using App Engine. Cloud functions. So let's have a quick look at cloud functions. So cloud functions is an event in the cloud, basically. So it's an event driven service. You could use Cloud PubSub. So I'm sure you would have heard of PubSub. It's a highly durable and high throughput application. So I would ask you guys to go check it out if you're not aware of that. It's fantastic for seeing the changes in the cloud storage, and also it would serve the HTTPS requests that are coming through. So it's a fully serverless. So it's for serverless service. So although I say serverless, there are servers beneath it, and you don't have to worry about that. From your point of view, you just deploy a piece of function and we run it for you if something happens. So you only pay for what you use, so as simple as that. And then it's based on Node.js runtime, so you could take it out and then run it on your machine and see how it's working as well. So it's very possible, very easy for you to test on your machines. And when you think of events, so it's basically when you think of about cloud functions, it's basically the events and the function definition. So something comes in, so basically something happens, and then you get the function to work in a way that you want, and there's an output that's coming out of that. As simple as that. So we think cloud functions is really good for serverless computing. So if you have low weight ETL transformations that you would like to do, so this is a good fit for that. And anything on the PubSub or the cloud storage integrations with that is also super good. And so we could think it of as the cloud-based HTTP glue. So if you're working on a complex application, so you could use the cloud functions to duct tape around your microservices and create a service for your customers as such. From a constraints point of view, it's only on JavaScript or Node.js at this point in time, and it really works at a very low granular level, and you must interact at an event based on an event driven function, as simple as that. So let's do a quick demo. I'll go back to the screen. So I've created a cloud function for you. So if you go here, that's there. So let me just show where to find this. So this is where you could find cloud functions right under the compute. So you have it here, and then you can see the cloud function, and you can see it's hosted in your central one. And let's see the trigger. So the trigger is actually a HTTPS function. So let me quickly open this, and you can see it says no message defined. So let's have a quick look at the code behind this. So there's fairly simple code written here. It says no message defined if you do not send any message. But let's say you want to send a small piece of message, and I'll just copy this and I'll test it here within the screen. And then let's say, so I'm going to send hello cloud on air viewers, and let me quickly test it. There it is. It says success, and there it is. And you also have a bunch of logs that are accumulated as part of this. So you could go through the logs and see if something's going wrong, or you could. It's easy. It's very easy for you to actually debug. So as simple as that. So you could also create cloud functions based on other triggers. For example, this one is based on a cloud PubSub topic. So, and you could also use one for the GCS storage. Cool. So let's get back to the slides. So why do you have to use cloud functions? So you don't have to think about service. All you have to deploy a piece of code, and then we will run it for you. And you only pay for what you use, and then it gives us a really simple experience for the developers as such. So where should I run my code? So we've talked about number of services that we offer, but some of you would have figured out by now that which is probably the best place for you to run your code or software. But some of you are still confused, and I would say that's okay. If you've not found it today, that's fine, absolutely fine. There's a bit more tips around where you could see your choice be around. So let's say, so it really depends. So it could be on the abstraction level that you want to really play. There could be some technical requirements around the application that you're developing, so that could help you take some decision. Or you could also look forward to your team and the organization that you're working in. So the team skills and the organization strategy around which technologies that you would probably want to work should also be taken into consideration before picking any one of these services. So when you talk about abstraction levels, it's a summary of what we have discussed so far. Cloud functions is event driven basic functions, and App Engine is basically HTTPS requests, and Container Engine is basically for the applications. You think about application, not the computers or containers as such. Compute Engine, then if you're dependent on you can run your code, you can customize the operating system, disk, images, CPUs, RAMs, a lot of things around that. From a technical requirements point of view, so the more technical requirements that you would probably have on your application, it would probably pull you down on the stack. So let's say you are confined in certain set of languages, then you would probably look at App Engine. And then let's say you should also look at the network traffic that is coming, network protocols that you would probably want to use, and then you have to run through a hybrid environment. Then Container Engine probably is a good fit. And then further down, if you have more requirements around the GPUs or the kernels that you're using, if you have some licensing requirements, then Compute Engine would be probably a better fit. So from a teams and organizations point of view, the cloud functions and app engines are mostly around the dev focused teams, and Container Engine and Compute Engine is basically for IT ops guys. So if you've not made the right decision, that's okay, as I've said earlier, not to worry about it. But the idea is that you could, if you use containers, you could actually move through all the three layers within App Engine, Container Engine, and Compute Engine. As I've said, if you run something in App Engine, you can create a Docker out of it, then you can host it on Container Engine, and then also on Compute Engine as such. And the idea is that it's very easy to move from up to bottom, but it gets slightly difficult for you to move from bottom to up. In a real world, however, though, we see that systems could use a multiple set of services. So maybe you could use App Engine along with functions to serve a specific workload, or you could see Container Engine along with the Compute Engine stitched together with cloud functions. So it really depends, to be honest, and coming back to what we have been saying. So just to summarize, so cloud functions, event driven, App Engine is for your web facing code, and Container Engine for its containerized applications, and Compute for the existing systems that you're already in it. So let's look at, I think that's pretty much what I would like to convey today. So as part of, and the next steps is that, you could always, there's a bunch of suggestions here. You could get certified. There's a link here on the slide that you can see here. It says cloud.google.com/training. So there's a bunch of information around how you can train yourself and also certify. And there's also quick labs, so you could play around a little bit on each of these functions on hands-on labs. And then you could also learn about Google Cloud Platform on Coursera, or you could contact us. There's a free $300 credit where you get when you sign up. So please feel free to use that as well. Cloud OnAir. Thank you very much for joining us today. So we're going to move on to a quick question look at some of the questions that have come through. We'll discuss them in a minute.
Thank you so much, Ashish. That was great. Now we have a
Thank
couple
you.
of questions that we need to answer from our, which have been asked by viewers. So I'll quickly just take up the first question. I'll read it aloud.
Sure.
So, can I get a database as a service with this? Example, a permanent or managed database as a service? Or do I need to install my DB on my OS and run it myself?
Well,
So-
yeah, thank you for that, Shasta. So again, the answer is it actually depends. So to be honest, you could bring your own database and then install it on a VM as a compute engine, or we also offer you managed SQL instances where you could do MySQL and Postgres, where we offer fully managed service. So an app engine can be integrated with a MySQL backend, so that's a good way of use case. But essentially, it depends on the application need that you have. To be honest, yeah.
Great. Thanks. So I think we have a couple of questions on load balancer as well.
Yep.
So this one says load balancer on GCP doesn't need pre-warming like another cloud provider.
Yeah, so so this is one of the benefits that you get from GCP. So your load balancer is actually a global load balancer. So you could scale from 0 to 1 million requests per second without any pre-warming. You don't even have to call anyone in the support or us to make sure and to handle the traffic that you're getting. For example, Pokemon Go. So you could see the craze that was there a few months ago. So it was all dealt by these load balancers in Google Cloud Platform. Yeah.
Awesome. So I think we have a follow-up question to that as well, which says that is it the load balancing automatically scales up and down depending on the number of instances?
So it's basically on the traffic that you get. So if your instances is powerful enough to serve the traffic that is getting through, so your instances wouldn't scale. I mean, assuming you have a managed instance group, but the load balancer actually scales based on the traffic that's coming in. So that, and then if you need an additional instance, if you're set in a way that it auto scales for the instances as well, the instance could also scale. But to answer the question, it's basically on the traffic that's coming in.
Awesome.
Yeah.
Okay. So here we have one of the questions about Cloud Function. Compared with Cloud Function, what is the difference on typical use cases?
So Cloud Functions is something, it's purely serverless. So it's event driven. So let's say there's a HTTPS request coming in, or there's a piece of data being added to your Google Cloud storage, or there's a message being delivered on your Cloud PubSub messaging queue. Then you could trigger for something to happen. So you could write a piece of code on Node.js and then deploy it, and then for it to work, or maybe let's say there's a JSON file coming into your Google Cloud platform, and you want to change it a little bit and serve it somewhere else. You could do that, and then and then there's an output at the end. It's